So good morning everyone. So for today's morning, I'm going to report on my given topic, which is the applications of combustions analysis. So combustions or burning, as it is more commonly known, is simply the mixing and exothermic reactions. We already know that exothermic is releasing heat from the surroundings or the outside of a fuel and oxidizer. So oxidizer is a substance that oxidizes to another substance. It has been used since prehistoric times in a variety of ways, such as source of direct heat, as in furnaces, boilers, stoves, and metal forming, or in piston engines, gas turbines, jet engines, rocket engines, guns, and explosives. Automobile engines use internal combustions in order to convert chemical into mechanical energy. Combustion is currently utilized in the productions of large quantities of hydrogen, or H2. Coal or coke is combusted at 1000 degrees Celsius in the presence of water in a two-step reactions. The first step shown is to involve the partial oxidations of carbon to carbon monoxide. Carbon, the gas, plus the H2 or the water gas to carbon monoxide gas plus H2, the hydrogen gas. The second step involves a mixture of produced carbon monoxide by water to produce hydrogen, and it is commonly known as the water gas shift reactions. The carbon monoxide gas plus the H2, the water gas, to carbon dioxide gas plus hydrogen gas. The history of combustions. In the 1780s, Anthony Lavoisier, as the first to analyze the organic compounds and combustions using an extremely large and expensive apparatus that required over 50 grams of the organic sample and a team of apparatus. So Anthony is a French chemist and renowned as a father of the modern chemistry. So the second is the method was simplified and optimized throughout the 19th and 20th centuries, first by Joseph Gay Lussac, who began to use copper oxide in 1815, which is still used as standard catalyst. So Joseph Gay is a French chemist. The third, the William Pratt invented a new method of combustion analysis in 1827 by heating a mixture of the sample and using a multiple flame alcohol lamp and measuring the change in gaseous volume. So William is an English chemist, physician, and natural theologian. In 1831, Justin Boog Liebig or Liebesch in German word Liebesch simplified the method of combustion analysis into a combustion train system, and that linearly heated the sample using coal, absorbed water using calcium chloride, and absorbed carbon dioxide using potash. So Justin is a German chemist. Jean-Baptiste Andre Dumas used a similar combustion train to Liebesch. However, he added a U-shaped aspirator that prevented atmospheric moisture from entering the apparatus. As you can see, his apparatus, they are U-shaped. So just Jean-Baptiste is a French chemist. So in 1923, Fritz Friegel received the Nobel Prize for inventing a microanalysis method of combustions. This method required only 5 mg or less, which is 0.01% of the amount required in Lavoisier's apparatus. So Fritsch is an Austrian chemist and physician. So that's all for my report. And then the next reporter will be the Kevin, and the next is Sydney Tercer.